Dear students, I hope you are all well and studying in your home. Last week, in the chapter The Periodic Table, we discussed about Mendeleev's periodic table and its merits and demerits. Today, we will study long form or extended form of the periodic table. It means the present form of the periodic table means new or modern periodic table which we used nowadays. The long form or extended form of the periodic table is based upon the fact that physical and chemical properties of the element are the periodic functions of their atomic numbers. This is also known as modern periodic law. As you understand that Mendeleev's table says us that the properties of elements are periodic function of their atomic masses, but now we accept this theory that the elements are the periodic function of their atomic numbers. In this periodic table, the elements are arranged in the increasing order of their atomic numbers. When the elements are arranged in the increasing order of their atomic numbers in accordance to the periodic law, they get arranged in such a way that elements having similar physical and chemical properties appear in vertical columns. These vertical columns are called groups or families, as same as Mendeleev's table. The long form of periodic table is shown in table 5.2. So this is the long form of periodic table. Okay, so if you understand this table, you easily give any question answer related to periodic table. So understand this table is very much necessary for this chapter. Okay, structural feature of long form. There are some features also. The horizontal rows present in the periodic table are termed as periods. As you see, okay, these rows these rows are known as periods. Okay, and these vertical columns are, I already told you that these are groups. First period is sorted periods. It contains only two elements. When you read this chapter, when you read this sentence, just look at the periodic table also, and you will be understand more better, and these things will be kept in your mind for future also. Okay, first period is sort test period. So if you see this first period, okay, one is written here, only hydrogen and helium is there, only two elements are there. Okay, this was written also here, hydrogen and helium, their atomic number are 1 and 2 respectively. And second period contains 8 elements. They are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Thus this is, it is a short period. Okay, first period is shortest period, and next is only uh, 8 elements there. Okay, and this is short period, known as short period. So you can match also, this is second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, now third period is also a short period and contains 8 elements. It has also 8 elements. These are sodium, we just go to the periodic table, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. Okay, understood till here? Fourth period contain 18 elements there. Okay, here are 18 elements in fourth period. If you see in periodic table, these 18 elements are there. Okay, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, okay, arsenic, selenium, bromine and krypton. So these are 18 elements found in fourth period, and in 50 period it is also contain 18 elements from rubidium to xenon. Okay, and you show in period table also. Seventh period, seventh period is now also complete period. It contains 32 elements starting from francium to you can look here, seventh period. Okay, from you can say that 87 atomic number to 1 818 atomic number it contains. Okay, and this also reported recently in last few years. Okay, the important feature of different periods are shown in table. Okay, in short, there are given important features of periods. Okay, first is shortest period, number of elements 2, atomic number 1 and 2. Okay, and short period, second period was short period, and third period also short. Okay, and so on. You can see elements present and their atomic numbers. Okay, in short form it was given. Now we read characteristics of period. Each period starts with the filling of a particular cell. For example, the first, second, and third periods start with the filling of K, L, and M respectively. Okay, each period ends when the octet is attained. When octet is attained, then the period ends. The last element of each period is a noble gas, which was either a duplet in case of first period or an octet. For example, the last element of first, second, and third periods are helium, neon, and argon respectively, which are noble gases. In each period, on moving from left to right, the incoming electrons are added successively in a particular cell or in the cell of lower energy. If it is still short of electron, for example, in the first three periods, the filling of electrons takes place as shown in table 5.4. So you can see in first period, okay, atomic number 1 and 2, okay, K in electrons will be K shell, okay, and electronic configuration is 1 and 2. So for second period, okay, the electrons cell in which incoming electron enter first in L cell, okay, and the electronic configuration will be 2 and 1, and so on. These is take place. So you have to do, you already know the how to write the electronic configuration. So it was very easy for you that Na281, okay, then last electron which will be enter in come into the cell is in M cell. Okay, M cell. In a period, the number of electrons cell remain the same and is equal to the number of period. Okay, in a period, the number of valence electrons, that is the number of electrons present in the outermost cell, successively increase by 1. The properties of elements present in a period vary in a regular fashion or moving from left to right. Now we read about the groups. Vertical columns present in the periodic table are referred to as groups. The long form of periodic table consists of 18 vertical columns, which comprises of 9 groups in the long form of periodic table. Okay, Mendeleev's scheme, or 18 groups in the new IUPAC name. Okay, so in Mendeleev scheme, the vertical columns from 9 groups 1 to 8 and 0 groups, except 8th group and 0 group, all other group have been subdivided into two groups, a subgroup and B subgroup. The arrangement of these groups from left to right in the periodic table is 1A, second A, okay, third B, and so on. So you can see in your periodic table also. This is 1A, 2A, okay, third A, fourth A, like this. This is third B, fourth B, okay, and so on. In 1984, the International Union of Pure and Applied Chemistry recommended a new scheme for the nomenclature of these groups. This scheme is known as IUPAC scheme. According to the IUPAC scheme, each vertical column present in the periodic table is regarded as separate group. The groups are numbered as 1, 2, 3, 4, and 18, so on. Okay. Thus, starting from left to right, we have group 1, 2, 3, and in last 18. So some characteristics of groups are the elements present in group have similar type of electronic configuration. Okay, if you see, for example, in first A group, all the elements possess only one electron in their outermost cell. Okay, these all are elements of group first and their atomic number, but if you see, their outermost electron have one electron in their outermost cell. all it or elements have. Okay, and on moving down a group, electron cell increase by one. The physical properties of element present in particular group vary in a regular fashion. Okay, and so on. One more important factor is here: the elements of lanthanide and actinide series possess outer three cells incomplete and are referred to as inner transitional elements. And variation in the properties of elements in the periodic table, from which many questions are asked. Okay, in exams also many questions will be asked in your future, so you have to read carefully. Okay, you also try to read, and we uh, discuss about them also in next class. If you find any confusion, you can anytime contact with me. Thank you.